Good morning. In this session, I am going to explain you the problems based on resultant velocity, that is in particular in case of a boat crossing a river. So, here let us consider a river of width S. So, let S be the width of the river. This is the width of the river, and VB is velocity of boat. VB is velocity of the boat. VW is water velocity, velocity of water. T is time taken to cross the boat, to cross the river. Time taken to cross the river, right? And here in the first case, case 1, he wants to reach, this is the first case, say, he wants to reach exactly the opposite bank. To reach exactly opposite bank. Opposite bank, or to cross the river, or to cross the river in the shortest path. Shortest path. What shall we do? Look here. Suppose this is, suppose water is flowing in this direction. This is the direction of water velocity. The person starts here. He wants to reach exactly the opposite bank. Suppose if he directly rows his boat in this direction, because of water flow, he will be moving in this direction. So, in order to reach exactly the opposite bank, the person has to row the boat in this direction. So, this is the velocity of boat, and this is the angle at which the boat is rowed. And actually, if water is not flowing, the boat reaches this point. But because of water velocity VW, boat exactly reaches the point B. So, here what we want to know is, the person here wants to reach exactly the opposite bank. In order to reach exactly the opposite bank, he has to row the boat at some angle with the normal of the flow. Actually, this is the flow direction, this is the normal of the flow. With the normal of the flow, he is making an angle theta. So, now we want to find out theta. So, from that diagram, sin theta is opposite side by hypotenuse, that is VB. So, the angle at which he should row the boat normal to the flow in order to reach exactly the opposite bank is theta is equal to sin inverse VW by VB. This is one very important formula, directly we will be using. And now, what is the time taken to cross the river? So, in this direction, the resultant velocity of the boat becomes VB square minus VW square. So, the time resultant displacement in this direction is S, resultant velocity is square root of VB square minus VW square. Hence, time taken by the boat to reach exactly the opposite bank here is, it is S by root of VB square minus VW square. So, this is the case where we wanted to reach exactly the opposite bank while crossing the river. Let us say the next case. Here the second case is to cross the river in the shortest time. To cross the river in the shortest time. Okay, so let this be the river of width S here. Okay, the person starts from the point A. VB is velocity of boat, VW is velocity of water. To cross the river in the shortest time, he rows his boat. He rows his boat, or he should row his boat normal to the flow. Normal to the flow. This is the most important hint here. So, to cross the river in the shortest time, he should row the boat in this direction. So, this is the velocity of boat. But because of water flow, he reaches a point down the lane. So, he finally reaches this point B. Now, this is opposite point is taken as O, say. OB is known as drift in the boat. X is called the drift in the boat because water pushed the boat through a distance x in the direction of flow, and this represents water velocity. And coming to the resultant displacement of the boat has started from this point A and finally reached this point. This becomes the resultant displacement. In this direction, the resultant velocity of the boat is VB square plus VW square. So, just look at the diagram given there. Here we want to cross the river in the shortest time. To cross the river in the shortest time, he should row the boat normal to the flow. So, this is the actual direction of boat. But because of water velocity, boat will be drifted through a distance x. So, this represents water velocity. This represents the displacement of the boat and this represents the resultant velocity. So, see here, from triangle law we can say time S is S and V, see here, the time taken to cross the river is S by VB. In the same time, the boat is moving through the water is moving through a distance x. So, that is x by VW. In the same time, the boat actually displaced through S. So, that is equal to S by root of VB square plus VW square. See here. So, here the time taken to cross the river in the shortest time is S by VB, that is also equal to x by VW, that is also equal to S by root of VB square plus VW square. So, next let us see another case. In any arbitrary direction, case 3, in any arbitrary direction. Arbitrary direction, that is, look here, once again this is the river, this is the width of the river. He is moving, rowing his boat with a velocity b at an angle theta. Okay, because he doesn't know the exact velocity of water. Suppose if water is flowing with higher velocity than he expected, instead of reaching exactly the same point, suppose this represents water velocity. So, this is the starting point and this is exactly the opposite bank, but finally because of that water velocity, he reaches this point B. This OB is called the drift in the boat from exactly the opposite point. Okay, in this problem, you may be asked to find out the net displacement of the boat, drift in the boat or time taken to cross the river. So, let us think about the problem carefully. I am explaining. S is the width of the river. Boat is rowed at an angle theta with a velocity Vb with the normal of the flow. But water, as he expected, water velocity is not exactly as he expected, but it is more than expected, say. Then naturally water pushes the boat forward because of its more velocity. So, x is the drift in the boat. Now, here, this is Vb, its component along this direction, theta is given here, this component becomes Vb cos theta, component along this side becomes Vb sin theta. Now, this resultant velocity in this direction is Vw minus Vb cos theta. The resultant velocity of the boat in this direction is Vw minus Vb sin theta. Vb sin theta. Okay? So, in that time it has travelled through a distance x. So, that is x by t. And another thing is, in the same time, this component is Vb cos theta. So, the distance covered here is width of the river in the same time. So, as Vb is known, S is known, theta is known, we can find out the value of t. By substituting that value of t here, you can find out the drift in the boat. So, just two simple concepts here. I am repeating. See here, in this problem, the person starts from this point. Actually, he thought of moving to this point. So, he rowed his boat in this direction at an angle theta with the normal of the flow. But water is flowing with more velocity than he expected. So, instead of reaching exactly the opposite point, he reached a point B down the stream. So, we call this OB as the drift in the boat because of the additional velocity of water. So, here if you resolve this Vb into components, this component becomes Vb cos theta, this becomes Vb sin theta, and S is the width of the river. So, Vb cos theta is equal to S by T. And in the same time, the drift in the boat is x and the resultant velocity in that direction is Vw minus, Vw is in this direction, Vb sin theta is opposite. So, resultant of two vectors in opposite direction, Vw minus Vb sin theta, that is equal to x by t, right. So, substituting that Vw minus Vb sin theta is x by t, Vb cos theta is S by t. From that you can find out t as well as the drift in the boat. Thank you and bye-bye.